I'm Matthew Stevens. I'm the technical manager here. If you've dealt with me at all in support or support team, I've likely dealt with you directly or one of my associates has. Yeah, I'll be doing the Breakline sessions this afternoon and tomorrow morning. Last year we did a single session of Breaklines, and it was quite condensed. I think a lot of people weren't able to really grasp what we were trying to do. We're just kind of moving too fast and hitting too much in one session, so we've kind of broken this up this year. It says introductory and advanced, but really what this is today we'll be going over water bodies, think ponds, lakes, things like that, implementing that as a surface, referencing that as a surface so you can get a nice clean feature for the surfaces you're generating. And then tomorrow it's going to be linear breaklines, think curbs, think walls, drainage ditches, things like that. All right, so I'm just going to jump right in. This is exercise 370 in the exercise document, if you want to turn to that. I don't think we gave you guys an electronic copy of this, unfortunately. I'm going to read a little bit of this, but I'm just going to try to summarize as well. I'm not just going to just read these sentences to you verbatim, or try not to, but I mean, basically, this download is the 2025 LP360 UC Breaklines Part 1. That's what this is. And as you probably notice, it's a really tiny file. I don't think anyone should have had issues downloading this, but just let me know if you did. As anything from our cloud side and a lot of the newer zip files, you'll notice that Windows just struggles with them just really bad. They'll say, oh, it's a corrupt file, something like that. But as long as you use 7-zip to unpack it, you should be fine. Which is exactly what I'm going to do. All right, everybody turn to 119 that's following along. Okay, cool. So like I was saying before, there's a need for, you do a laser collect, and usually around water and ponds, things like that. The data is really noisy, and you just have a lot of issues getting a good surface off that. So we classify that water out, the noisy data, and then we basically draw a ring around to represent where the water line is, and then we're able to represent that surface. So that's basically what we're going to be covering today. A lot of times, you can see the very first part of this exercise, we're converting a 2D to 3D. A lot of times you may be provided from an outside source a file for, oh, this is the extent of the water. Can you implement this in the collection you did? And assuming the coordinate systems line up, all your ducks in a row, you shouldn't have any issues with that. We'll be going over different kinds of conflation. And what I mean by conflation is we're just matching the vector file, a polygon, a point, a line, any kind of shape file or feature. We're trying to match that up with the point cloud. So, and there's different ways we can do that. As you've noticed, if any of you have been looking at laser scanner data, a lot of times there's a thickness to it, and, you can peer through, the vegetation and different features. You've got different features in the data set. So you don't necessarily want to just focus on just the surface. Sometimes you want the minimum value in that spread of data that you have, or the maximum value, or it just depends on the context for what you're trying to do. So we're going to go over some of those conflation types and why we would use, those different types. We even have, we'll see if we have time to cover this, but there's if you're trying to digitize a stream, you start off with digitizing the center line of the stream, and that conflation is called downstream constraint, and it basically it forces the line to go downstream, so it will actually burn through the last data. So not only is it conflating to the surface or the minimum value or max, but there's also some intelligence to how some of this is run as well, to try to conform to the feature you're trying to collect. And then we're going to generate a quick DEM after we go through the exercise. So you should have the LEZ files. There's two. There's a UTM. There's a state plane. We're going to start with the UTM. We're actually, just as get you more exposure to tools in LP360 to start off with, we're just going to do a quick reproject of the data so you can see what that looks like. I don't know if you guys have done that before, but we'll go over that. And then there's some PCTs to import as well, and some water bodies. And there's a linear feature component to this exercise, but we're probably going to skip that today because we're focusing on that tomorrow. So we only have so much time, so let's jump right in. So start up LP360. And I think, yeah, we have it where we import the data first. So just go ahead and click the top option, add files to map. Just let me know if you can't see what I'm trying to demonstrate. Click add files to map. Go ahead and in the LAS tab at the top left, click the plus button, and then select. I'm going to go ahead and go to. So as you'll notice when you hit the plus button, I'm going to go to the spot where you had unzipped the files. You'll see, okay, you don't see any LAS files. It's because they're LAZ files. These are compressed files. So in the bottom right, change that to LAZ, and then select the UTM file and click open. And we're just going to use the default settings here. Yours should look similar to mine. Ian probably went over this in her session, but when you add a LAS file, you can see additional information here. If you click this little advanced setting in the top right, you can see the coordinate system, some other things about the data, what version it is, that kind of thing. I'm going to click OK. It's fine. Read only is fine. It's fine. Because we're not going to actually do anything with this file. We're going to immediately reproject it just so you guys see what that looks like. Okay, so your screen should look something like this. And so I'm immediately going to go to project and save the project. Just pick a spot to do it. Now, just kind of it's a little bit of an Easter egg. You can click the location to save it. If you just immediately click select folder, it's going to save it in the exact same location that the initial file came from. So it's kind of like a little, if you're just trying to, if you know you want to put the project in the same spot, then it's a really easy way to do it. And I'm just going to call this UTM. This is, I think I called this Breaklines original UTM in the exercise. You can call it that, but you call it UTM is fine. Notice that LP360 automatically read, if the information is available in the LAS file, if it's formatted properly, it automatically read the coordinate system information from the file and set up the project in that automatically. So that's kind of nice. You don't have to go in there and set that. But if let's say you had a LAS file that wasn't formatted properly, you knew the coordinate system reference information, but it wasn't there, you could go ahead and define that at this point in time. I'm going to go ahead and click Save Project. And it's just telling me, hey, do you want to create this project in this location? I'm going to say yes. All right, so at this point, just, and I think Ian probably covered this as well if you guys attended her sessions. We brought in a PCT group. Go to Point Task at the top. Click on PCT Manager. Just let me know if I'm going too fast. I mean, I've done this a million times, so if there's times I may be going too fast, so just slow me down if I'm losing you. Click on the Import button. And then what we want to import is that custom exercise Breaklines PCTs. Click Open. It'll populate. You can see I've already populated this before, so I think it automatically doubles up for me. But you should see that in your list. And a good way for you to test that it was imported and properly, click on Groups. You should see Breaklines water bodies. Let me know if you don't. I'm going to click on that. And then once I've clicked on that, I'll click on Favorites and I'll click on water bodies again. And you can see the PCTs that are associated with this exercise. Just let me know if you have any issues with that. Okay, so we should have those PCTs loaded. And the reason we did that is because we're about to run one. We're going to run the, it's called Reproject to Kansas State Plane US Feet PCT. So click on your Point Task tab at the top. For you, it's the Point Task tab at the bottom. We used to have it down here. We've moved it into the ribbon. You can decide whether or not yourself if you think it's easier to do it that way, but we tried to make it more user-friendly. Filter by groups at the top left. I'm going to select group. It's just telling me, okay, hey, whatever PCT you're on, it's not in this group. It's just giving me little warnings. You can read them, but it's just trying to prompt you along the way. That's all it's doing. It's just doing that again, saying, hey, this whatever PCT you're on, it was not in this group. Then set your active to that 0, that reproject to Kansas state plane feed. All right, just let me know if I lost anybody. I lost somebody? Oh, okay. Christy, let's check it in. We got a lot to cover, so Christy, just let me know if you have any issues. Let's see here. Just making sure we're running this right. Yep. So I'm just going to glance at this PCT real quick. I'm just going to gloss over it. I'm going to go to, if you want to look at any point cloud task settings, go to active PCT settings. And you can see we're reprojecting from our current UTM coordinate system. And we've got all the proper reference frame information. And we're going to Kansas state plane. So I'll run that by active LAS layer here at the top. One thing too, before I run that, the output is set using our project path option. I'll go to that one more time. It's this guy right here, the output folder. We're using project path. And this is already set up for you guys, but it's this little button right here. Use that, and then you can just basically design your folder structure from there. But it's already set up for you to run. Go ahead and run by active LAS layer. It's just saying, do I want to do that? And this is a incredibly tiny file, so it should take no time at all to run. So at this point, notice that no other layers are showed up in my table of contents. LP360.
See, I'm getting epic errors. A lot of people says, yeah, I know that too. Epoch is
So it's just giving you a warning. It should let you continue on. That's just a warning. Sometimes LP360, depending on the datums we're going to and from, there may be an issue going from datums, and it's just warning you like, hey, there could be an issue potentially. That's all it is.
Saying some validity do already. It runs if you change the source at Epoch to 1997. Mine was at 2010.
Oh, yours was at 2010?
Yeah.
Okay, yeah, change the source epic to 1997. It should have already been set the way. I'm sorry about that. Yeah. That should get you going. Jared just retyped the numbers and it worked. So now this file is already in the project data anyways. So if you struggle with this, if you're having failures, we can just reference that file as well. So, all right, should have produced the file. I'm going to go ahead and go into File Explorer. You can go ahead and go to Project, close Project. And this is just telling me, hey, do you want to, if you made any changes to your LAS data, you can update the LAZ file based on those changes, but we didn't, so it's fine. All right. So let's see what we produced. This is a project and this is the output. That's labeled like that. You can go ahead and reference that if you want to. Now, like I said, we already have this file in Breaklines sp.laz already in the folder. So if you want to go ahead and reference that as well, that's perfectly fine. But we're going to create a new project based on that. So I'm going to go ahead and, just so I don't get confused, I'm going to rename that to SPC. Just keeping track of my time. I'll just copy this to the top layer. But like I said, you can always reference the file that's already there. I'm just showing you the operation of reprojecting with that PCT. So click Add Files. If you weren't able to do the reprojection, then just reference I'll show you, the LAZ file, the Breaklines SP. If you were able to do the reprojection, you want to reference that, then you can do so at this point as well. So I'm going to go ahead and do that. Well, you'll have to, like I said, what you'll do is, what I did is I went to project in the top, I closed the project, and now I've gone to this add files button here in the middle, and then you can add that file that you produced from here, or the breaklines.sp if you had any issues, the LAZ file. This is the file I produced from that operation. Just let me know if anybody's having issues getting there. All right. And just use the default settings. If you want to, you can have the set to read right in the bottom left. We can also do that later as well. I'm going to click OK. There's my reprojected data. Just let me know if anybody's having issues with that. Okay. You just keep going in this exercise to make sure I'm following along with you guys. Let's also add a WMS layer. So here at the top, there's right to the right of Add Files dialog, there's an Add WMS. And you've got some different options here. I'm going to click Google Hybrid and then close. And you should see a base map come in. Let me know if you don't. Okay. And then I'm going to add one more additional file here. Right up here at the top, feature. So click on the feature tab this time instead of the last tab. Click on the feature tab. And from that data set, from the unzipped data, select water bodies. Click open. It tells you the feature type at the top. It's a polygon 2D. That's not going to do as much good with breaklines, but we're going to don't click OK yet. If somebody was chomping at the bit, don't click OK yet. But we're going to convert that to 3D. Go ahead and select this file. As you can see, is also in UTM. We're going to click transform feature files to map SRS at the bottom. It's giving me a warning, same kind of datum conversion issue, but it should let you click through it. Let me know if it doesn't. And then click OK. And you should see a file populate in that area right there. Let me know if you don't. Okay. Just see where we're at. So let's just zoom into that western area of I'm just using my scroll wheel and just hovering up my mouse cursor over the area that I want to zoom in on, and then just zoom in on that western side of that lake. Switch from points here at the top. You see where I'm at the toolbar above the map view. Switch that to wireframe so we can see that. And let's see. We're going to go ahead and adjust the breakline settings, and you'll see how the 2D doesn't affect this data. So I'm going to hold down control, and you see this little button here. It's right to the right of contours. Hold down control and click on that, and it should pop up this LAS Layer 1's properties menu. This is also, that's just a little Easter egg, but I find it far more intuitive to hold down control and left click on the option that you want to change settings on, rather than going to active LAS layer properties and then sorting through this. So you can also find that setting right here. But I'm going to hold down control and left click on that option, use breakline enforcement, turn on water bodies. And it says in this document to view a number of buffer classes. This is this modify classes button at the bottom right. Click on that. And for this, you'll just want to choose ignore ground. That's good enough for our buffer classes because all our other classifications already are going to be done. All right. So the buffer classes are going to eat into the other classes, so it's really not necessary to choose other options. And you can perform on the fly topology corrections. It's really only if you've got more than one source layer. We're only going to have one source layer, so I'm going to click OK. And this is basically toggling this button on and off that's what's determining breakline enforcement being on. As you can see, there's no change at all to the point cloud because it's a 2D file. Let's go ahead and I think in the exercise as well, it has us turn on contours. We can do that real quick too. So click on the contours button, and then again, hold down Control. And then when you're clicking on smooth contours, it'll pop up the settings dialog. Again, you can find this in active LAS layer properties, but I just find it, again, more intuitive if I hold down Control and left click, and it just brings you right to the option I'm wanting. Let's set a user specified interval of 3 feet. That's right here in the kind of the middle of the dialog. All the other settings you can leave by default if it should be set like this. Just let me know if you're having issues with that. Click OK. And then you can click on the contours button again at the top, the drop down, and click smooth contours, and it'll start displaying them. It's important. Right now we're displaying by all points. Go ahead and switch this top up here. Switch that to ground system. Okay. We're going to be doing some classification, but just for the purposes, once we start doing classification, you'll be able to see the changes more readily when we start doing that if we're filtering by ground system. All right. So I believe the next thing we're going to do should be, I've kind of breezed through, we're on page 125, and I've kind of breezed through a lot of this verbiage here in this. Essentially, we've zoomed into an area where we can see the changes we enforce breaklines, and it says zoom to level of, if you haven't noticed this already, we have a scale here at the bottom, the very bottom of the dialog, where my mouse is, and tells you the scale. So you can actually manually set that scale, or you can see it change as you zoom in and out. So it's saying go to a scale of 1 in 100, or 1 in 150, or 1 in 50. And there's scale 1 to 71. But just make sure you're zoomed in so we can see this change to the breaklines. And now we're going to run a PCT to convert this 2D breakline to a 3D breakline. Notice too, if you're avid users of LP360, when you select a feature in LP360, it shows up as this cyan color. And you notice that sometimes when you even create a feature, it's going to give it that cyan color, which is really annoying. So one thing you can do in the table of contents, right-click on the feature, go to Properties, and you can alter how the feature is displayed any way you want. So I'm going to change it to red, increase the size so you can see that feature a little bit better. Now go to Point Task at the top, and we're going to run the 2D to 3D water bodies PCT. This is just giving me an epic warning. Let's see. I chose the wrong PCT. 1 second. Let's see. There we go. Make sure you're choosing the right PCT when you're doing this. All right, so let's just see what this is doing. So it's going to reference, it's going to form a conflation on this feature while we're converting it to 3D. So it's going to conflate it to the ground and water classification, which is already done on this data set. And conflation method, if you click on the option in conflation method and then double click on the option, so again, do the drop down and double click on the option, the drop down, you can see basically how it's running the conflation. So for this one, and for any water body for that matter, you're going to want to create a flat 3D feature. So it's basically going to take an average of all the Z values, all the elevation values around the body of water, and it's going to create a single value for all those points. So you'll have a nice flat feature. So that's what the second option is. And we've chosen minimum Z for the value. That's typically what it is. You know, you want that minimum value, the minimum part of the bank. You want that to represent the edge of your water body. Click OK. And that's it. So it's going to run that, and it's going to create, if we look back, it should be creating a 3D based on that. So when we run this, we're going to run this by feature layer. Okay, and water bodies, click run. And what should have happened, and for you guys as well, it should have created a new water bodies 3D feature. And notice, again, this is the same kind of thing. It's the same color as my contours. That's kind of annoying. So I'm going to turn off my 2D water bodies in the table of contents. Right-click on that, go to Properties, because it just chooses colors at random. And then I'm going to change that to, maybe let's change to yellow. I'm going to increase the outline width as well to make it a little bit more visible. Okay. So you should see that in your map. Was everybody able to make a 3D water body that's following along? Okay, good. You weren't? Okay. You clicked run and nothing happened. Okay. See if you can assist him, Chris. See if I need help, I can. All right, now since we have a 3D water body now, click on the Breaklines button at the top that we were referencing before. Do a control left click again. Hold down control and left click. Uncheck your water bodies, the file we started off with, and then check your water bodies 3D. Click, and we'll change the modified classes again to ignore. It's already should be still set to ignore ground. Click OK, and see if I zoom in a little bit. I'm going to go ahead and turn, just so I can see this a little bit better. You guys can do the same. I'm going to turn off my WMS layer so I can it's kind of a little bit more visible in the black background. And I'm just going to toggle, after you've set the breakline setting, you can toggle it on and off, and you can see how we're changing that wireframe model. I'm going to switch this to 10 as well, here at the top. Switch that back to 10 surface, and we can just see how it's changing the surface in that spot. We still haven't done some things we need to do. One of the concepts here with breaklines, and anytime you want to enforce a breakline, you cannot have a 3D point from the point cloud in the same spot. There will be a topology error. You'll have all kinds of issues. So one of the things we always have to do when we make a breakline is we have to do a buffer classification on that breakline. So, and that's this next step here. This is step 20 on page 128. So we're basically going to run, let me just make sure we're on the right spot. Yep. So the step 20 here on page 128, this is, we're performing that buffer classification. It mentions typical values you would use for buffer classification, but we've picked something quite big. I'm going to go ahead and pull up the PCT for this. It's the reclassify by 3D water bodies. This is performing that. What we're doing two things. We're classifying within the polygon. I'm just going to do a quick zoom out. You don't necessarily have to, but we're going to classify all the points within this. I'm going to, again, you don't have to follow along with me right now. I'm just going to show you what we're doing. Switch this to all points. I turn off my contours. It's going to slow things down. So we're basically going to classify all the points inside this water body as water, and then we're going to perform a buffer classification around the feature. So just to ensure that there's no topology errors, there's no conflicts with the original points and the breakline we've created. In this instance, we're referencing a breakline we already had. I'm going to go ahead and zoom back in on the spot. You guys are probably still there, hopefully. You got a wireframe. I'm going to switch back to elevation and turn it on and off. Again, make your active PCT number 1, reclassify by 3D water bodies. Click active PCT settings. And this is a macro. So there's an option. You don't have to follow me along. I'm just going to show this to you real quick. Go to PCT Manager. You can click Add here in the top. And the task type is macro. You can basically run multiple PCT sequentially. So in this instance, we're going to classify inside the water body, like I said, and we're going to perform that buffer classification on the feature as well, both at the same time using a macro. So that's what this is. The input points is ground here. So I'm going to go and switch this back to ground so we can see what's going on. And we're basically moving those. For this first one, we're doing the buffer classification, and the second one, we're classifying within the polygon. And you can see if you look down at the bottom, we're classifying within a distance of, again, this is a really exaggerated value, 5 feet. Destination class, it's ignore ground. That's why we're using that as our buffer classification in our breakline enforcement settings. And then for classify water, I'm just messing with this. So I'm going to hit save. You don't necessarily have to mess with this while I'm messing with it. Then the other one for classifying within the water is completely within. So of course there's no distance setting with that. It's you're using that for classifying a polygon and everything within it. And it's to the water classification. Click OK. And I'm just going to go ahead and run this by feature layer again, but run this time not on water bodies, but your water bodies 3D. Okay, and then click run. This is a really small data set, so this should all run very fast for everybody. And you see what it's done. If we're filtering by ground, we're no longer seeing the points that were classified as water. We're no longer seeing the points that were part of the buffer classification. Excuse me, let's just go ahead and toggle breakline settings on and off, and you can see how it's manipulating this. One other thing I mentioned in the exercise, now we're getting to step 21 on page 129. A lot of times you'll want to maybe make a slight adjustment on the elevation value. Maybe you know what the elevation value is for the edge of the water body, and you can go ahead and set that now. So I'm going to go ahead and click on the Feature Edit tab at the top. You'll have a Feature Edit toolbar in yours, but you can just watch if you'd like. I'm going to go ahead and click Select here in the top left, the arrow. I'm going to select the feature, right-click, and we've got some different options here. I'm going to click Shift Selected Feature, and then I'm just going to basically move it down 1 foot. So for Z, I can just put -1. Click OK, it's going to move it down 1 foot. And if you're happy with those edits, I'm just going to, again, just watch. You don't necessarily have to follow along. If you knew what the elevation values you wanted to use, you could, instead of doing Shift Select a Feature, you can do Shift Select a Feature 2. So I'm going to select that, and then you can set the Z to whatever you want it to. But let's say I'm happy with it. I moved it down 1 foot. I'm going to click Save Edits. And now that breakline should be enforced. I'm going to change this from wireframe to 10 surface. This is going to really show as being pretty drastic here. So you can see now we have a really nice, for our surface, we have a really nice flat feature to represent when we're doing our exports. I'm going to go ahead and turn my breakline off, and you can see how it goes from being that nice smooth surface to having all kinds of issues with the elevation when not enforcing that. If we're just using the point cloud without the breakline, to, even though we've done all the classification properly, all that's correct, you know, you've got different elevations all across this in your point cloud. You know, there's a little bit of a noise profile anytime you have laser data. So without that breakline, you don't have that nice smooth surface, and then when you do your export, it's just going to have issues. So enforcing that breakline, you can see it has a nice smooth surface. Hopefully everybody is seeing that on their end. That's a very good question. Because I used such an exaggerated buffer, it didn't matter in this scenario. But let's say you're making a really tight buffer, like I think like on page 128, we say typically 1/4 to 1/2 the nominal point spacing, but you want a minimum distance of 1/4 of a foot or 1 foot. But yeah, so if you did a buffer of 1/4 of a foot or a foot, and you moved it more than that, you're right. You'd have to redo that buffer classification for that to turn out correct. That's exactly right. That's a good point. But because we use such a massive exaggerated value, we're never going to have that issue. All right, so that's really the first part of this exercise, is showing you, you know, someone's given you a file or you have an existing file and utilizing that as a breakline for a water body. For this next piece, we're going to actually create one from scratch. Everybody up to speed so far? Okay, all right. So go ahead and use your cursor wheel. Just so you know, and Ian may have covered this, go to Project in the top left, go to Settings here on the right, just go to Project Settings and go to Global. If you're unhappy with the direction of your mouse zoom wheel or wheel zoom, you can change that here. So you can invert the mouse wheel zoom and click OK. And then depending on what you have that setting, it's going to change what direction you zoom in and out with the cursor wheel. So that a lot of people complain about that and want to change that setting. So that's something you can always do. All right, so I'm going to go ahead and zoom out. And then there's this little kind of irregularly shaped water body here in the bottom right, or the southeast of the project area. Just go ahead and zoom in on that. And what we're going to do is we're going to create a new feature. So go to the Feature Edit tab at the top. I'm kind of loosely following along with the article. I just don't want to be reading this article to you word for word, or else it might become quite tedious. So, but I'm roughly following along with that. So let's just make sure I'm not losing anybody where we're at. So we already have an existing feature, so we don't have to create a new one. But let's say you needed to create a new one. In the top left here, there's a Create Feature Layer option, and if we have some time in this exercise, hopefully we'll do a quick downstream constraint, and I'll show you how to create one of those from scratch. But for right now, your active feature layer should be Water Bodies 3D. If for whatever reason it's set to none or Water Bodies, go ahead and change that to Water Bodies 3D. And we're basically going to digitize around the edge of this little water body. You'll click on this button, Create Feature, here at the top. Now, one of the things we want to do is we can go ahead and automatically conflate the water body edge however we would like. We already have some PCTs set up for this very purpose. You can see here below the Create Feature option, there's a surface mode. So this is the Z surface mode. So this is, you can toggle it on and off. If I were to toggle this off and create it, it's just going to create the feature at an elevation of 0, which usually isn't helpful for most people. I'm going to go ahead and toggle that on. Same thing. If you go to Feature Edit Options here on the right, you can go into the options for this. But again, I like to hold down Control for a lot of these and do a left click, and then it just brings me right to the option that's applicable for what I'm trying to work on. So for Surface Auto Z settings, you should have a 3D manual water bodies. Go ahead and select Edit Feature and Create Feature to that. So obviously we're going to have to set the Create Feature conflation task to the conflation method we want. But let's say we want to edit this as well while we're working on it. We can go ahead and set that to the same setting, and that way we can ensure the conflation is going to happen the same for both editing and creating our feature. So click OK. So now as we digitize this, it's going to use that PCT. If we want to see what that setting is, you don't necessarily have to follow along. I'll show you. Did a Control left click. You can see what that setting is here and manipulate it by clicking this little ellipse here on the right. It's going to bring up the settings dialog for that, and we can just take a quick glance at what we're doing. We're just typically when people are doing this, they already have some classification done. So ground's already classified, maybe even some water classified, maybe ignore ground's already classified. So typically the common settings are to have these set for your input source settings when you're digitizing this new water body feature to use as a breakline. And then Summarize Z, the setting we're using, is the same thing, creating that flat 3D surface, average of all the vertices we're creating, and then the minimum Z for that. So as we digitize, I'm going to have the profile view up so we can make sure we're in the right spot. But you'll notice that it really doesn't conform to the spot where we're clicking in the Z, and that's because of this setting. It's trying to do an average while we're clicking. So don't let that throw you. Just make sure you're in the right place horizontally while we're going through this. And yeah, you can pretty much, for what we're using this for is just the conflation setting for Auto Z. The output setting is irrelevant, but if you were to run this separately, this would be the output setting for it. So I'm just going to go ahead and close that, click OK here. Go ahead and your LP360 session, click on the map option at the top and toggle your profile view. So just go ahead and turn that on. Go ahead and have that active. And let's change the thickness of that too. So you can modify profile depth here. My little mouse pointer option's not working, but it's this little option right here. It looks like a black square with some red arrows inside and outside of it. If you click on that, you can modify the profile depth. 5 feet's pretty good. Maybe I'll reduce that down even a little bit more to 3 feet. You could just change whatever profile depth you want. And as we start to digitize, let's see here. Make sure you have draw a profile box on, draw a profile center line. It should follow along if you have the profile up as we digitize. Just let me know if you have any issues with that. So just zoom in to the edge of this feature. You can turn contours on to help you with that, kind of find the edge of the feature. And then just left click to begin. Let me just see where we're at in the exercise. So I'm not completely losing everybody. We are on page 132, and it's step 29. So left click. One thing I did not do to show you guys feature edit options here in the top. I'm going to go ahead and click on that. And under geometry, go ahead and allow horizontal vertex movement. And that's the only setting I want you to alter, and click OK. And you'll see why in a little bit.
Sorry, other
feature edit options here at the top right. And in the feature edit tab, sometimes I jump around sporadically, so just, question me if you lose, or if I lose you. And just start digitizing. Now, it's really important whenever you digitize a polygon, we're considering what's inside of it. So the way that the logic works is what's inside of a polygon. To reference that, we draw it clockwise. If you want to reference what's outside of the polygon, draw it counterclockwise. Don't panic if you draw it counterclockwise. It's no big issue. Once we're done making this and you reference the feature, there's an option up here where I'm hovering. You can reverse the geometry of a selected a feature you've created. So don't panic. It's not like you have to start from scratch digitizing if you digitize it counterclockwise. So I'm going to zoom in just a little bit more so I can see where I am. I'm really not doing a great job being on the edge of this, but I think if I was being really methodical here, we'd be here for a while. So I'm just going to just kind of get close to the edge. Maybe I'll go back here and change my profile depth. Let's make it 10 feet so you can just see what's happening, because this is a pretty sparse data set. And you should see some points here that represent the edge of the data. And you can see if I zoom out just a little bit, if you click on this zoom out here, it's gonna blow away your feature layer, but that's okay. I'm just gonna zoom out just a little bit so you can see where we're at. You can see we're missing points where the water is, which makes sense, right? So I'm gonna go ahead and start digitizing again, clockwise. And I don't know, for whatever reason with this specific function, it really doesn't start to pick up until maybe the third or fourth click. So don't let that throw you either. Eventually it'll start to pick up and you'll see it. And let's say, okay, I want it to really be at the edge of this. So you can move this horizontally wherever you want. So you can see how I moved it right, or maybe I don't want to be right at the edge. Maybe I want to be a little bit inside, just a touch. Notice how the profile is perpendicular right now. As I just go ahead, and you don't have to be too careful with this. Just try to get as close to the edge as possible and just left click around it. Bless you. You notice now, look, my profile is all out of whack. I really need that profile perpendicular to the direction I'm digitizing so I can see the edge of that water body properly. If you just do a middle click with your mouse button in the profile view, hold down shift and use your arrow keys, you can rotate. This is kind of an Easter egg. You can rotate that profile however you want. So now I'm rotating it to where it's perpendicular to the direction I'm drawing, and say, let's just say, okay, I honestly, I think I digitized it just fine, even if this is a real world scenario, but we'll say, I'm unhappy with this. I'll just go ahead and move this horizontally a little bit. And you can see in the map view how it's actually moving when I'm just going to move into a crazy location. You can see how it's moving that vertex in the map view when I move it in the profile view. All right. And so I'm just going to go ahead and keep clicking around. You can see I made kind of a bad click here, kind of a weird digitization here. You can always, if you're unhappy with how you're clicking, right click, just right click anywhere in the map view and click undo, and you can undo what you've already done. And now see, I'm back to where I was. Exactly. Remember earlier when we were talking about conflation settings, you can change it to be for editing and creating. I set it to the same as for editing. So watch. I'm going to go ahead and finish the digitization. He's asking about moving these vertices after the fact. So I'm actually going to even goof up even more. You guys just go ahead and try to draw this as best as you can around the water feature. Let me know if anybody's having any issues. But I'm going to take what you said a step further. And maybe I follow this contour. Maybe that's the edge of the water line. And let's say you want to have even more granular contours as well. You can do a control left click on the smooth contour setting again. Let's say maybe I want 1 foot contours, so I could change to that and click OK. And now I've got a few more that I can play with for finding the edge of that water body. Bless you. Let's see. All right. I'm not being super careful, and we're just demonstrating the concept here, so it's a great question. We have an article for that. So let me show you that while you guys continue to, we got our knowledge base, and actually you can get to the knowledge base by clicking support at the top and clicking on knowledge base. It should bring up browser right up. And there is an Easter, this is support.lp360.com. And if you just type in Easter eggs, there's your Easter eggs article. And pretty much all the Easter eggs I'm showing, it's right here in the article. So for different views, for different different functions, there's multiple Easter eggs. So that should help you out. Yep. All right, so I'm going to continue digitizing. And I just had someone ask, like, what if you made a mistake? What if you wanted to, let's say, alter, if you're going to alter what you've already done. So let's say you're clicking really fast. I'm left clicking around this. And to finish the feature, you double click. So let's say I accidentally double click. I'm going really fast and double click. I've made this and it's like, oh crap, I've done all this work and now it's messed up. I can actually go into feature edit. You don't have to do this with me, but I'm just going to show you. Go to feature edit here, select at the top. And I can actually select and edit vertices, and I can add. So not only can I select, so all I have to do is select a vertice or multiple vertices. I can left click and hold and select multiple and move them where I want. Let's see. I can also move single vertices, but I can add vertices, and mine's not going to look as pretty as yours because you should be doing this a little bit by hand, but this vertice I added, I can move it way over here, and then I can just add vertices in between. To kind of, and see, we'll see, I messed up there. I can make all kinds of edits to these as I see fit. So in the feature edit tab at the top, there's all kinds of options for selecting vertices. And when you select them, you can left click and hold and move them around. Not only can I move them in the map view, but you can move them in the profile view like you saw as well. I can add, delete, I can do all kinds of interesting things. But as you were saying, you can move them. This is an already created feature, and I'm creating and editing vertices after the fact. So it's pretty neat. So I'm just adding in between where I goofed up, essentially. Let me know if anybody's having any issues with digitizing that. And when you get to the end of where you want to digitize to, you double click to finish, and it should finish the feature. Just let me know if anybody's having any issues. Maybe I'll move this guy a little bit farther north. And let's see, I just moved my whole feature layer away from the water on accident. Just click we have an undo redo, so I'm just going to click undo. It's going to move it right back. So don't, as long as you haven't saved your edits or discarded edits, you're in this editing session, it's really easy to undo redo everything you've done. So there's no need to panic if if I'm like you saw me, I moved this to some crazy spot. Don't panic, just hit undo and you're good to go. So I'm going to go and wrap up my digitization. Just anybody interrupt me if they're having any issues. Like I said, mine's not going to look as pretty as yours probably, but you'll get the gist of what we're doing. Let's just go ahead and move this guy up high here. You can see, I mean, this is not like how you would typically do it, but if you had done a lot of digitization work on a feature and you wanted to try to salvage it, you can do kind of like what I'm doing, adding vertices in between. Yeah, and I think we probably need to improve here is if I click on the zoom, it's going to blow away my edit session. I mean, I've already created the feature now, so I'll be fine. But if you're making a brand new feature and you hadn't already finished creating that, it's going to blow away the work you've done. So I think really that's the improvement we need to make is the ability to zoom in and out a little bit easier while you're digitizing. Let me just see if I can force. Yeah, so if you hold down Shift and use your scroll wheel, you can zoom forwards and backwards as well. But zooming in and out, like if I click on this little magnifying glass right here and I haven't made the feature yet, it's going to blow away what I've done. So that's probably something we can improve. Let me go ahead and finish this feature real quick so we can move on in the exercise. Hopefully everyone's gotten to that point with theirs. Mine's going to look really ugly, but that's okay. I'm glad you asked that question about editing the vertices so I could show that off. Just taking me a little bit longer because of that, but it's okay. I think we're finished up. All right. So let's say I'm happy with it. I'm just going to go ahead and save edits. And we're going to do the same thing we did before. We're going to go to your point cloud task, and let's run, the group should be water bodies, and go to your reclassify 3D water bodies. And you'll run that again. Now, wait before you run. Click on the feature edit toolbar at the top, or the tab at the top. Click on the select edit at the top left. Excuse me. And I'm going to select that feature. Now click on point task. Now click by feature layer so you can run on selected features as well. So I know I've already run it on the other water body, so I don't really need to rerun it again. That's kind of redundant, and especially if you had a lot of water bodies, if it was a really complex project, you don't want to rerun on like 100 bodies of water. So I'm going to click run, and it's going to run on just that single feature, and it should turn out. As long as you have your display settings similar to mine, now we've got that nice breakline enforced water body, and hopefully everybody's seen the same thing. Let me know if you're not. All right, so that's pretty much it for the water bodies. The next part of this this exercise has us reviewing linear features. If you want to in your own time, you can import those and play with those. But I mean, we have a whole session on linear features tomorrow, so I don't want to get too sidetracked on that for this session. That I left that in the exercise in case you wanted to play with that. So right now we should be on, let me find the spot because we've been kind of jumping around. So we're on step 38 on page 136.
in that.
Yeah.
So right now that gray line, is it to average itself out?
Yeah, so
So like the people in the vertices are all the same.
they're all the same. That's right. So it's basically it doesn't determine the elevation until you're finished in digitizing, but it'll take an average of all of the. So if you're really reckless with your digitizing, then your break line's not going to be very great, right? You've got to really draw it that close to what the edge of the water body is. But then at that point, it'll average out. After you complete, it's going to put it at that elevation that's an average of all those points. So, and let me just show you that one more time. It's a great question. Let me just show you what that. Let's go to our 3D manual water bodies, go to active PCT settings, summarize Z setting. So it creates a flat 3D feature and it's assigning the same Z to each vertex based on selected statistics for the group. So in this instance, it's the minimum Z. So the average minimum Z for the group, that's what it's going to select. So that's it. Okay. Any other questions before I move on? I think we have enough time. We're going to go to, let me see if we're going to skip there's a road linear features in this, and we're going to skip that. So actually, if you don't mind, I think we have enough time. Let's go to page 134, and this is step 32. So we're going to show just how to make real quick. We don't have a lot of time. Then this is a complex subject. We could spend half a day on this, but we're going to just show you how to make a downstream constraint centerline. So basically in this, I'm just covering, on that step, I'm covering what the settings are for that, but we're going to digitize that. So we can start there with that. So this is something I want to show you guys anyways. Click on the feature edit tab at the top. In the top left, I want you to create feature layer. You should see some little pop-up like this. Select geometry type, select 3D polyline, and this is what's important with this. Enable M values. There's only one feature in LP360, as far as I know, it's still this way. There's only one feature that's actually using that M values attribute, and that's how we're tracking different things as you're digitizing a feature. And M values in this instance is, remember before I just briefly mentioned this, when you run downstream constraint, the feature is trying to burn through the LAS data to try to keep going downstream as you digitize, or upstream depending on the direction you go. And this M value is saying, okay, what's the delta of that? How much did it have to burn through the data to make it fit? If it's burning through too much, then you probably have some issue with your data. So that's what's just kind of warning you. Maybe you've selected the wrong place for your centerline. So I'm going to click Browse up here. Just select a spot where you want to place this. I'm just going to call it centerline. I think in the exercise, I'm having you make an additional linear feature, but like I said, we're really focusing on linear features tomorrow in the morning exercise. I'm going to go and click OK here. Okay. And now just zoom out, and I'm going to zoom in on the profile to the area that's to the southeast of that first water feature we had. And you can see we've got a lot of elevation change by looking at these contours. So we're just going to start digitizing over there. What I want you to do is in the feature edit tab, again, hold down Control, left click on the surface mode on the far left, right over here. Change that to manual stream centerline. We're going to look at those settings real quick. You can just watch. You don't necessarily have to follow this with me. And we'll just look at what that downstream setting is, saying create a vertex, X amount of map units, and see it says flip geometry if drawn upstream. So it's forcing it to stay downstream as you're digitizing. And then these deltas, see where it says all these deltas, these are my M values, is telling me if it exceeds a foot, if we're having to adjust it more than a foot as we're digitizing, it's going to basically give me a warning, and it's going to populate that in the feature attributes. So I'm going to click OK. Input points filter, it should be set to ground, and it is groundwater, ignore ground, the same kind of features you'd have around classification for around water features and doing ground classification. Click OK. So we've got that set up as our edit and create feature task. Same thing, I'm going to have my profile up. And then I'm going to start, hopefully everybody's okay. I'm going to start digitizing. So I'm going to hit create feature again. And I'm just going to start in the spot where I think is the center of the stream area. Just kind of zoom in and see how the contours can help me determine that. And you can see we're here right centered up. Say, okay, I'm really not centered up the way I want because of the feature edit options setting from before. Remember, we had set the horizontal for text movement. Now I can move this horizontally in the profile view if I wanted to. And like we were talking about before, let's say I'm not exactly perpendicular to how I want to be digitizing. This is an Easter egg. Do your middle mouse button click in the profile view, hold down shift, and use your arrow keys to kind of make this perpendicular to your digitization direction so you can get that centered up. I'm not going to be super careful here. I'm just going to click through just for the sake of time. But you can be as careful as you want to be. Notice how there's some kind of misclassification here. And this was left here on purpose so you can see how it kind of burns through the data. But I'm going to click around that. I'm not going to click on top of it. I'm going to click around it. But you'll see how it'll burn through that. If you did misclick, it would just go straight through it. So we missed some vegetation. We were doing ground classification. So, I mean, honestly, if you're the user, you go back and reclassify this. But this is just to demonstrate how the downstream constraint burns through the data. So, not to wear that terminology out. And then just double click to finish whenever you're done digitizing. I'm just going to pick an arbitrary place to stop. See, immediately it tells me, okay, the maximum allowed displacement delta was exceeded. It's just giving me a warning. It's not stopping me from creating it. It's not, this is not an error message just saying, hey, you might have an issue here. So click OK. Now we've got that downstream constraint center line. I'm going to right click on that, go to feature analyst, click on the feature, and now let's click on the individual vertices, that tab. Just let me know if I'm going too fast. And look, we have all our M values here. If I scroll down, you can see, okay, it's telling me that when I click that 6th vertice, I had to make X amount of change to keep that downstream constraint going. So you can kind of use this to troubleshoot. Like maybe I clicked off to the side of a stream, or maybe I'm in a drainage ditch and I'm just not being careful enough in my digitization. So it's just giving me a warning. I'm going to go and close that. And let's just see how it did. So what I want you to do now, let's save edits. And then what I want you to do is, you guys probably notice a lot of this. I'm kind of going off the reservation a little bit. What's in the exercise document? It's kind of like step 1, step 2, step 3, but I'm just giving you kind of practical instructions here. So I'm not trying to just throw this to the wayside, but for the sake of time, I'm not just reading that out verbatim to you. Click on the map tab at the top. Click on the draw 3D view, and then just left click and hold, and let's kind of lasso that spot where we did the downstream constraint. And now I want you to toggle, this is the display legend, I want you to toggle that off, and you can see how this is, even though we've clicked in spots, you can see there's lots of noise here. And, if we had our conflation set a certain way, that would mess our downstream constraint all up. You can see how it's burned through that data, and it's continued to go in downstream direction. Of course, there's some additional things in here. Anybody that's interested in downstream constraints should look at our documentation about. We've got multiple articles and multiple tutorials of that on our knowledge base at support.lp360.com. But just, a lot of people, when they do this, they're going to use that reference, that center line we just created, and then make the riverbank features to go along with that. And just, I don't have time to cover it in the session, but if I go to the feature edit tab, that's your double line drain tool up there. So do a little bit of searching in our knowledge base about that, and that's the workflow for creating the banks based on that center line. Before we run out of time, let's go ahead and make a digital elevation model based on the work we've done. So this is just so you have a point of reference. Now we're at We're on. Yeah, we're back to 136 and step 38, but I'm just gonna kind of go quickly here. But that's kind of where this is picking up on. So what I want you to do next is click on the project option at the top left. Click on the export wizard. Okay, it's right here, export wizard. And then select for export type. It tells you the settings we're setting on step 39 on page 137. Those are the settings we're setting. So I'm going to select surface. I'm going to change the cell edge length to 5 feet. Change the breakline enforcement to water bodies 3D. Same as what we were doing before when we were displaying the water bodies. Excuse me. Modify class is the same. Ignore ground. Click OK. Input points. We're doing all this with ground, so ground system is your input points. Click OK. And for our export type format, we're going to select GeoTIFF. Click Next. Let's not do basic extent here, just for the sake of time and just so we're focusing on the features we're interested in. I want you to select Draw, Window, and Map. Click on the Draw tool option, and then left-click and hold over the area that you want, and then stop when you're got. We're just lassoing the area that's on the western side where we had that nice big water feature that was well defined. Click Next, and then just select an output location. I think we had a specific name that we were using in this exercise, but I'm just going to call it DEM. You can place it where you want. Save. And you don't have to run this in the job manager. You can, for just keeping track of your exports, you can do that. But just for simplicity's sake, we're just going to run it directly in LP360 as a small project. And we're going to insert outputs to maps. So hit Finish. You should see something like this. And if we zoom in, we can see we've got a well-defined water feature from our breakline. Let me know if anybody's not seeing that. So we can say, okay, great, we have our DEM. Like, how do I know that the DEM's okay? Or let's say another thing we want is I've got my point data set. It's a bunch of randomized points with LAS data typically, as you guys have noticed when you're dealing with this data. My DEM has this nice gridded data set, so we can make a LAS file based on the DEM and also check the DEM and make sure that what we created is correct, and also make a gridded data set at the same time. So click on in project, click on add files at the top, click on DEM to LAS up here, click the plus button, and then just reference that DEM that we've already brought in. Okay. One thing that's probably a good idea, you don't have to do this, but I like to do this since I know it's ground data. For destination class here at the bottom, set that to ground. Okay. Click OK. Click OK again. And now you should see something like this. So if we zoom in, you can see it's a gridded data set, which is what sometimes certain clients need that gridded data set. And for our active LAS layer on the top left, let's just switch to DEM LAS layer. Change from points view to 10 view. And now you can see we're checking the validity of that breakline enforcement in the DEM we produced, and it looks pretty good. Obviously, like we'd already discussed, there's some major busts in the ground classification, the downstream constraint area, but that's just so we could demonstrate that conflation method. All right, so the last thing in this exercise, let's go to, this is page 140. This is step 46. You can make some people need a XYZ ASCII file produced, gridded data set produced from, for a surface or for a deliverable for the end user. So again, go to the export wizard at the top. Select we can do this a couple of different ways. You can export This, you can keep this surface and do the export format as XYZ like this. However, if you want to, you can select the export type as points, XYZ, and now look, on the left side over here, I have many more options available if I want to for defining the data. So you don't necessarily have to, but you know, if you have the data point in the data, intensity, classification, anything listed on here, typical LAS file attributes, you can include those as well in the file. So I always tell people that. Sometimes someone's like, hey, I really want to know, you know, let's say what the point source ID was for this point. You know, we can, what flight line that was from, we can specify that here, assuming that that's currently present in the data. Input points filter, it really doesn't matter. All the points are in a single class, but you know, it's going to have to be either set to ground or all points, you know, for this to work properly. Again, make sure you're referencing as your active LAS layer, that DM LAS layer 1. Otherwise, this is going to run forever. You're going to have some trouble. Anytime you make an ASCII XYZ file, it'll make a massive file if it's a lot of LAS points. But we have a small subset here, so this is a perfect scenario to use this. Hit next. I'm just going to use basic extent this time. Next. And I'm just going to select an output location. I just clicked on this button here in the top right. Select an output location. So I'll just call this XYZ. Click Save. And then hit Finish. It takes no time at all because this is tiny. And I'm just going to go into my project folder where all that's located and just go to my XYZ file here at the bottom. And there's all my XYZ points. So importing this into other software packages where you might need that. I mean, that's all I have for you guys this exercise. The breakline itself, that's a great question. So in the table of contents, right click. So on the breakline itself, right? Okay, so the breakline itself. So I'm going to right click on my water bodies 3D and hover over export, and look, you've got a number of options here. You got DGN version 7, version 8. You got DXF and KML2 if you want to bring that into Google Earth or something like that. Any other questions? Everybody good? All right, well, hopefully that was illuminating. And like I said, tomorrow morning, we're going to have a second session of breaklines, and we're going to focus on linear features. So think curbs, walls, drainage ditches, things like that. So, all right. Thanks, everybody.